Hi, my name is Peter Lee, and today I'll be talking about Lab 1. So, within this lab, we really analyzed how certain materials can acquire charges, and we observed how these charges interacted with one another. In our specific experience, we charged pieces of tape, and we noticed how they interact with one another in other objects that surrounded it. Um, One formula that's central to all of these observations is Coulomb's law, which states that the electric force equals K times Q1 times Q2 over R squared. So we observed pieces of U-tape. We created U-tape by taking a piece of tape and sticking it onto a surface. Then we took another piece of tape, we placed it on top of that tape, and then we pulled it up. And that created a charge on that top piece of tape. And we noted that that tape is now called U-tape. Whenever we had two pieces of U-tape, we noticed that they would repel one another. This must have meant that there was a repulsive force, and therefore they had like charges. U-tapes were also attracted to neutral objects, and we learned in lecture that this is due to the polarization induced by the charged pieces of tape. Third, the U-tape was attracted to a negatively charged pen. We can conclude that the U-tape was positively charged since the opposite charges attract according to Coulomb's law. Since if Q1 times Q2 is negative, there will be a negative force, and a negative force means that there's an attractive force. Whereas if Q1 times Q2 is positive, meaning that they have like charges, the force would be positive, meaning that there will be a repulsive force. Next, I will talk about the lab setup. The lab setup was as follows. We had a piece of U-tape B so that it sagged on an elevated surface. Next, we took a piece of U-tape A and we held it slowly and moved it slowly towards U-tape B until U-tape B began to levitate. This was when we knew that the gravitational force equaled the electric force. The electric force here was repulsive. Since U-tape A and U-tape B were of the same charge, they repelled one another. And we took the distance between the U-tapes. In order to calculate the electric force of the U-tapes, what we did was we noted that the momentum and the change in momentum of the U-tape was zero. So the acceleration was zero, and according to Newton's first law, the net force must have been zero since these were at rest. Next, we assume that all U-tapes must have had the same charge since they went through the same process of being created and they all had the same charge sign since they repelled one another. The net force was zero. Um, and because of that, the electric force must have been equal and opposite to the gravitational force. We calculate the gravitational force with the formula F equals mg, where g is the gravitational constant. Here's a free body diagram of the tape, where the electric force is equal and opposite in magnitude to the gravity. They have the same magnitude, my bad, but they have the negative and opposite directions. Here are my observations. I noted that the distance for the tapes had in order for tape B to levitate above tape A was about 0.02 meters or about 2 centimeters. And I also noted that the force of gravity equals force electric. The force of gravity we calculated to be 0.00196 newtons, and we set that equal to the magnitude of the electric force. And then we use Coulomb's law to solve for the charge of the tape. Since we knew the magnitude of the force, and since we knew that what k was, which was the constant 9 e to the negative 9, and since we knew the distance, we had all these, but the only thing unknown was the charge. So here, since we noted that Q1 is tape A and Q2 is tape B, and since Q1 equals Q2, we can simplify this expression to F equals K times Q1 squared over R squared. And solving for Q1, we're able to derive that the charge of one of the U-tapes is 9.33 times 10 to the minus 9 coulombs. Since the tapes have the same charge, since we assume that, we're able to calculate the charge of each of the tape with this expression. Finally, here's some of my code that I wrote to kind of simulate this model. The red indicates U-tape B, blue indicates U-tape A, green indicates the gravitational force, and orange indicates the electric force. Notice how these arrows are opposite, and they model the free body diagram where I had this magnitudes the same. And I was actually able to calculate the charge of the U-tape in this manner by using it as almost like a calculator. Finally, to answer some of your discussion questions, the first discussion question is, what if electrons had positive charge and that protons had negative charge? What would change about the observations you made about your tapes and other charged objects? I think that nothing would have changed. We would have had the same observations since uh, if you had two like charges and you flip their charge, they would still be like charges. And if you had two oppositely charged, like a proton and a positive charge and a negative charge, they would just become a negative and positive charge. So they would still be attractive to one another. So I think none of these observations would have changed since the U tapes would still repel one another because they would they would become positive charged U-tape to negatively charged U-tape. Finally, why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes into contact with your hands or other objects? What happens is that we discharge them and we neutralize the tapes by touching them, and we allow those charges to kind of distribute through us, and they become less effective. Thank you.